Hello student. Last time we have seen about bandwidth or fringe width. In case of interference pattern, bright and dark bands are equidistant and equally spaced in an interference pattern. Also, we have seen the relation between path difference and phase difference. Also, the conditions for obtaining steady and well-defined interference pattern on the screen. In this lecture, we will study the next point, methods for obtaining coherent sources. Coherent sources is one of the most important conditions for obtaining steady and well-defined interference pattern on the screen. The given two sources are said to be coherent. Suppose this is source S1 and this is S2. These two sources are said to be coherent if these two sources emit light waves like this. These two light waves having same frequency as well as constant phase difference, then such sources are said to be coherent sources. Such two coherent sources to be obtained by using two methods. One, light mirror. First, light mirror, and second, biprism. These are two methods for obtaining coherent sources. We can discuss one by one. First method for obtaining coherent sources is light's mirror. Light's mirror is a plane mirror as shown in this diagram. This is light's mirror is a plane mirror. This is vertical line shows the screen on which interference pattern is obtained. S1 be the original source of light. The light from source S is fall on the mirror by making some angle known as a grazing angle and incident on the screen. Some part of that light incident directly on the screen shown by these blue lines. These blue lines shows light emitted from source incident directly on the screen, but some part of that light incident after reflection from the plane mirror shown by the red lines. These are the red lines show some part of light is reflected by that light's mirror incident on that screen. In this case, this reflected light will appear from a virtual source S2. These are two sources S1 and S2 obtained by means of this light's mirror, and the light waves from these two sources interact with each other, produces well-defined interference pattern on the screen consists of alternate bright and dark bands, each band having same width and same intensity. In this way, we will obtain steady and well-defined interference pattern with the help of these two sources S1, S2. First source, original source, second source, virtual source. These sources acts as coherent sources, that sources to be obtained by means of this light's mirror to obtain steady and well-defined interference pattern on the screen. This is the first method for obtaining coherent sources of light, that is light's mirror. And second method for obtaining coherent sources is biprism. Biprism is a special prism. Special purpose prism is made up of two thin prisms like this. This is first thin prism and this is second thin prism. These are two thin prisms joined together with their bases हे दोन प्रिझम आहेत, थिन प्रिझम, हे आपण एकत्र जॉईन केले बेसला, मिळून जो प्रिझम तयार होईल त्या प्रिझमचं नाव आहे बायप्रिझम. तो प्रिझम कसा असेल, तो असा असेल पहा. दिस इज बायप्रिझम made up from two thin prisms combined together with their bases. Such a figure is called as biprism. This biprism having very large vertex angle about 179 degree and very small refracting angle near about 30 minute to 1 degree. Such a prism is called as biprism. With the help of that biprism, we can obtain the two coherent sources as follows. Consider this biprism. This is a biprism kept a source of light in front of biprism in the form of slit. This is source of light in the form of slit kept in front of that biprism, such that refracting edge of that biprism exactly parallel to that slit acts as original source of light. Suppose this is screen on which we observe steady interference pattern on the screen. This is screen. Light from source S is allowed to fall on that biprism like this. Light after refraction through that prism incident on the screen in this way. We consider another rays emitted from source S incident on biprism like this. After refraction, these rays incident on the screen like this. Then we will get a region of interference shown by these vertical lines. This is a region of interference. If we proceed these rays in backward direction like this ray is proceed in backward direction like this, represented by the dotted line. This ray is proceed backward, represented by the dotted line like this. Then we will obtain the another two sources, S1 and S2. These two sources are virtual sources obtained from original source S with the help of this biprism. These two sources called as coherent sources of light. Light from these two coherent sources allowed to incident on that biprism interact or overlap with each other in this region, and we will get steady and well-defined interference pattern on the screen consists of alternate bright dark bands having same width and same intensity. In this way, we will obtain two coherent sources. Two methods for obtaining coherent sources. One, Light's mirror, and second, biprism. This is about methods for obtaining coherent sources. Then next point is optical path. Optical path. What is meant by optical path? पाथ मराठीमध्ये आपण सरळ सरळ ज्याला म्हणतो मराठीमध्ये पाथ म्हणजे मार्ग किंवा रस्ता. एखादी लाईट वेव्ह किंवा एखादी वेव्ह एका मीडियममध्ये दुसऱ्या मीडियममध्ये जेव्हा ट्रॅव्हल होईल त्यावेळी त्या वेव्हची वेलॉसिटी बदलते, त्या वेव्हची वेव्हलेंथ बदलते, ती वेव्ह आपला मार्ग बदलते. हे आपण आतापर्यंत शिकलेलो आहोत, हे आपल्याला माहीत आहे. हे कन्सिडर करून आपण ऑप्टिकल पाथ ही कन्सेप्ट काय आहे ते आपण पाहणार आहोत. फॉर दॅट कन्सिडर a single light wave like this. This is a single light wave. One wave, single light wave having crest and trough. One crest, one trough together form a single wave, and the length of that single wave is called as its length, called as wavelength of that wave. Length of wave called as its wavelength, denoted by symbol lambda. Wavelength is nothing but distance between two successive crests or trough in case of wave, or distance between 2 points which are in the same phase called as wavelength of that wave, denoted by symbol lambda. One cycle constitutes one wave. बघा, एक वेव्ह म्हटलं की इथून इथपर्यंतचा पोर्शन म्हणजे वेव्ह. ह्या वेव्हची लेंथ किती असते? लॅम्बडा. म्हणजे वेव्हचा पाथ, जो पाथ आहे पाथ, तो त्या वेव्हच्या लेंथशी रिलेटेड असतो. म्हणजे कशाशी? वेव्हलेंथशी रिलेटेड असतो. तसंच ही वेव्ह जर आपण कन्सिडर केली तर ह्या वेव्हमध्ये आपण जर अँगल कन्सिडर केला तर तो कसा असेल पहा. 0 इथं असेल π/2, इथं असेल पाय, इथं 3π/2, इथं काय असेल 2π. म्हणजे अँगलच्या बाबतीत जर विचार केला तर एक सिंगल वेव्ह म्हणजे अँगल किती राहील बघा? 0 ते किती असेल बघा? 2π. म्हणजे पाथ लॅम्बडा करस्पॉन्ड्स टू फेज 2π. फेज रिलेटेड विथ अँगल ऑफ दॅट वेव्ह, पाथ रिलेटेड विथ wavelength of that wave, means lambda path or path difference related with that wave. पाथ डिफरन्स लॅम्बडा असेल तर फेज डिफरन्स किती असेल? 2π असेल ना. आपण एखादा पॉईंट जर आपण इथे कन्सिडर केला, सपोज पी बी एनी पॉईंट ॲट अ डिस्टन्स डेल्टा एक्स, एवढा अंतर असेल, मग एवढा पाथ असेल, तर त्याचा फेज डिफरन्स किती असेल आपल्याला कॅल्क्युलेट करता येतोय. लॅम्बडा बी दी पाथ डिफरन्स, 2π बी दी फेज डिफरन्स, देन डेल्टा एक्स पाथ डिफरन्स साठी फेज डिफरन्स किती असेल त्याची व्हॅल्यू आपल्याला काढता येईल. तो म्हणजे कसं का? डेल्टा फाय इक्वल टू 2π डिवाइडेड बाय लॅम्बडा इंटू डेल्टा एक्स. तो पाथ डिफरन्स किती, तो फेज डिफरन्स किती असेल पहा? डेल्टा फाय इक्वल टू 2π डिवाइडेड बाय लॅम्बडा इंटू डेल्टा एक्स, और डेल्टा फाय इक्वल टू दिस टर्म 2π डिवाइडेड बाय लॅम्बडा इज कॉल्ड एज प्रोपैगेशन कांस्टेंट denoted by symbol k. Delta phi equal to k into delta x. Suppose this is equation number 1. Consider this wave. It may be light wave traveling in positive direction of x-axis. The displacement of that wave given by the formula y is equal to a sin omega t minus kx, where a be the amplitude of that wave, omega be the angular frequency of that wave, and k be the polarization constant. This angular frequency omega equal to 2π upon t. We have the formula omega equal to 2π divided by t, where t be the period of that wave, and this k, propagation constant k equal to 2π divided by lambda. Suppose this wave is traveling in one medium to another medium. एका माध्यमातून दुसऱ्या माध्यमामध्ये जर लाईट ट्रॅव्हल झाली तर त्या लाईटची वेव्हलेंथ बदलते. म्हणजे काय? लॅम्बडा चेंज होतो, लॅम्बडा वेव्हलेंथ ऑफ दॅट लाईट. जर लॅम्बडा चेंज झाला तर केची व्हॅल्यू सुद्धा काय होणार? चेंज होणार. म्हणजे पोलरायझेशन कॉन्सेप्ट सुद्धा काय होईल बघा? चेंज होईल. कधी? लाईट एका मीडियममधून दुसऱ्या मीडियममध्ये ट्रॅव्हल झाली तर लॅम्बडा चेंज होईल, त्यामुळे केची व्हॅल्यू सुद्धा काय होईल? चेंज होईल. We have omega is equal to, sorry, k is equal to 2π divided by lambda, multiply and divide to RHS by t like this. कॅपिटल T. RHSला आपण T ने मल्टिप्लाय केलं, T ने डिवाईड केलं तर इक्वेशनमध्ये फरक पडत आहे. आपण टर्म रिअरेंज करूया. K इक्वल टू 2π डिवाइडेड बाय T, हा T मी इकडे घेतला, इंटू T डिवाइडेड बाय लॅम्डा. T डिवाइडेड बाय लॅम्डा. K इज इक्वल टू 2π divided by T into, we have some relation V is equal to mu lambda. In case of wave, we have velocity of wave equal to frequency into wavelength of that wave. Therefore, frequency equal to mu equal to frequency reciprocal of periodic time 1 upon T into lambda. Therefore, T divided by lambda is equal to 1 upon V. By rearranging the terms, we get T divided by lambda is equal to 1 upon V. Then substitute the value of T upon lambda. In this case, T upon lambda equal to 1 upon V. Therefore, K is equal to 2π upon T equal to 2π divided by T equal to omega into 1 upon V, means K is equal to omega divided by V. Suppose this wave traveling in two media, one in vacuum, that is free space, and second in medium. ही वेव व्हॅक्यूममधून सुद्धा ट्रॅव्हल होत असेल आणि मीडियममधून सुद्धा ट्रॅव्हल होत असेल तर त्या वेवच्या बाबतीत आपण हा फॉर्म्युला आपण असा घेऊ शकतो बा. इन केस ऑफ व्हॅक्यूम K can be written like this: K equal to omega divided by C, where C is the velocity of light in free space or vacuum, and medium, that K dash equal to omega divided by V, where V is the velocity of light in medium. Then we have the refractive index of any denser medium given by the formula N is equal to C divided by V. Refractive index of medium is equal to ratio of speed of light in vacuum to speed of light in medium. Therefore, V is equal to C divided by N. V is equal to C divided by N. Substitute that value of V in this formula. K dash equal to omega divided by V. Therefore, K dash equal to omega divided by V. V means C divided by N, equal to N omega divided by C. Therefore, K dash equal to N omega divided by C. This is the value of K dash, dielectric constant, when light travels in medium. Suppose delta X be the path difference when light travels in vacuum or free space. Then the phase difference of that wave while traveling through vacuum given by the formula delta phi equal to delta phi equal to omega divided by C into delta x. Therefore, delta phi equal to K into delta x. Delta phi equal to K into delta x. But this wave while traveling through medium, then the phase difference of that wave in medium can be calculated as delta phi dash equal to K dash into delta x, but K dash equal to delta phi dash equal to K dash equal to N omega divided by C into delta x, but omega divided by C equal to N omega divided by C equal to K into delta x, but K into delta x equal to delta phi. Therefore, delta phi dash equal to N into delta phi. This is the formula for determination of phase difference when wave travels through medium. That formula we written like this: delta phi dash equal to n times delta phi. If delta x be the path difference in free space and delta x dash with the path difference in medium, then delta x dash is equal to n times delta x. The formula is important for solving some examples related with optical path. Here we consider two medium, one free space and second medium. In time t, that wave covers some distance in free space as well as medium with some velocity. Then according to formula, velocity equal to distance divided by time. That is, v is equal to d divided by t, or t is equal to d divided by v. Apply this formula for two medium, one free space and second medium. Therefore, t is equal to distance covered by that wave in vacuum or free space, dv, divided by velocity of wave in vacuum, that is vv. Similarly, in case of medium, distance covered by the wave in medium, dm, and velocity of light in medium, vm. T dv divided by distance in vacuum divided by velocity in vacuum, t equal to distance in medium divided by velocity in medium. By comparing these two results, we write some equations. LHS is same, therefore equate RHS. Therefore dv, distance in vacuum divided by velocity in vacuum, is equal to distance in medium divided by velocity in medium. Calculate distance in vacuum, dv equal to distance in medium into this velocity in vacuum divided by velocity in medium. But velocity in vacuum divided by velocity in medium, ratio of velocity of light in vacuum to velocity of light in medium, is called as refractive index of that medium, denoted by symbol n. Therefore dv, distance in vacuum, is equal to distance in medium into n. Suppose delta x with the path difference, that delta x to be calculated with the help of formula, delta is equal to distance covered by the wave in vacuum minus distance covered by wave in medium. Therefore delta x equal to dv minus dm, but dv equal to n times dm, delta x equal to n times dm minus dm. दोन्हीमध्ये dm कॉमन घ्यायचा आहे, त्यामुळे असे फॉर्म्युला मिळतो डेल्टा x इक्वल टू dm इंटू ब्रॅकेट n मायनस 1 हा फॉर्म्युला मिळतोय. पाथ डिफरन्स डेल्टा x इक्वल टू dm इंटू ब्रॅकेट n मायनस n. समजा ही वेव आहे, लाईट वेव. ही वेव एकाच वेळीमधून, समजा अशा दोन वेव्ज आपण जर करूया, हे दोन वेव्ज आहेत, एकाच वेळीमधून पुढे पुढे चाललेले आहेत. तर ह्या दोन वेव्हचा पाथ डिफरन्स एखाद्या पॉईंट आपण कन्सिडर केला त्या स्क्रीनवरती, तर तो कसा असेल, पाथ डिफरन्स 0 असेल. पण समजा सेकंड वेव्हच्या पाथमध्ये आपण समजा एखादी ग्लास प्लेट ठेवली, ज्या ग्लास प्लेटचा थिकनेस किती आहे पहा, ती आहे, म्हणजे रिफ्रॅक्टिव्ह इंडेक्स किती आहे, n आहे. तर ह्या दोन वेव्हमधला पाथ डिफरन्स बदलतो, चेंज होतो. तो चेंज होणारा जो पाथ डिफरन्स आहे तो कोणता असेल बघा, दॅट पाथ डिफरन्स गिवन बाय द फॉर्म्युला डेल्टा एक्स इक्वल टू. आता ह्याच फॉर्म्युला आपण तो काढू शकतोय. तो कसा पहा, तर ब्रॅकेट n-1 इंटू डिस्टन्स कवर्ड बाय द वेव इन मीडियम. तिथे मीडियम कोणता असणार बघा, ग्लास मीडियम असणार आहे. ग्लास मीडियमचा रिफ्रॅक्टिव्ह इंडेक्स किती आहे, n आहे. त्याचा थिकनेस किती आहे, t आहे. म्हणजेच काय, ह्या वेवनं त्या मीडियममध्ये किती डिस्टन्स कवर केलं, तर त्या ग्लास प्लेटच्या थिकनेस एवढं डिस्टन्स कवर केलं. दॅरफॉर रिप्लेस dm बाय t. दॅरफॉर फॉर्म्युला डेल्टा एक्स इक्वल टू n-1 इंटू t. दिस इज द पाथ डिफरन्स which When a glass plate of thickness T having refractive index n is placed in the path of ray of light. This is about the optical path. आता ह्याचा अर्थ असा लक्षात घ्या, थोडक्यात आता समजून घ्या. एखादी वेव्ह जर दोन मीडियममधून ट्रॅव्हल होत असेल तर त्या वेव्हचा पाथ बदलतो, पाथ डिफरन्स चेंज होतो. त्याचप्रमाणे त्या वेव्हचा फेज डिफरन्ससुद्धा चेंज होतो. त्या पाथ डिफरन्सची आणि फेज डिफरन्सची व्हॅल्यू आपण वेगवेगळ्या फॉर्म्युल्याने काय करू शकतो आहे, कॅल्क्युलेट करू शकतो आहे. दिस इज अबाउट ऑप्टिकल पाथ. तर आता आपण इथं थांबूया. थँक्यू.
Should be